Good afternoon. My name is Cody Munson. This is my capstone project for Grantham University, ET450. GID is G00092005, the automated transmission service flush. Here we're going to be simulating the transmission service flush. We have an air compressor to pressurize the system. We have the bucket full of water. We have the two solenoids that are going to open and close and simulate filling and draining of the transmission fluid. It's going to go through this pipe and come through this bucket. Here's our Arduino breadboard. The circuit is composed of a couple of diodes, resistors, transistors, wiring, and a 12-volt battery source. As you can see here, we have the circuit and the Arduino. Just getting up a close glimpse of what's going on. The Arduino is being grounded to the breadboard. We have pin 4 and pin 6 as our high and low outputs from the Arduino to the circuit. Solenoid 1 will be operated off of pin 4. So we have solenoid 1 right here, and solenoid 2 is right here. Solenoid 1 is on the right side of the breadboard. The Arduino is not supplying any power to the breadboard, but it is getting its power from the laptop as we compile and execute the program and then initialize with the reset button. The Arduino output, high or low, initializes right there at the resistor, drops across. The transistor then switches, which gives the power to the solenoid, which is this blue wire here for solenoid 2. The solenoid pin for the power will go right here. It'll go to the solenoid, from the solenoid to the other side over here, which will then be attached to the positive rail of the breadboard from the positive and ground power of the 12-volt battery. I will be using the Arduino IDE software to execute the program that I've written. It will turn the solenoids on and off as we go through the program, and the transmission fluid, which is our water in this scenario, will drain into this bucket. I've added the air pressure from the air compressor. The bucket is now bubbling. The solenoids are clicking on and off as the program operates and the fluid comes out the other side. Now with this proof of concept, I can take this to work, show that the system like this would work, install solenoid valves on our conditioning stands, and work with the scripters to create an automated test where the service technician does not have to go in there next to the engine and transmission while it's running. It will increase the efficiency of the company, and it will also increase the safety of our technicians. The solenoids are still turning on and off, but I've removed the air pressure from the bucket. The solenoids require at least a 3 psi pressure to allow the fluid to run through them. So anything that's coming out now is residual pressure from the system. This concludes my video for the ET450 Grantham University Capstone Project. I hope you enjoyed it. If there's any questions, comments, concerns, please feel free to approach me with them. This project was very fun. I learned a lot. Thank you very much. Thank you for watching my video. I do believe that I've met all the requirements for the capstone project with Grantham University, from the initial design, the calculations, the programming, and the hardware installation, along with creating the circuit and using all the proper components to execute the project successfully.